All right, 7th graders, we're going to start talking about something new. Section 7.5 talks about linear inequalities. Now let's review a linear equation. A linear equation is when you draw a line. A linear inequality is going to be like an equation, but instead of just one answer or a set of answers that make the equation true, you are going to be shading on a coordinate plane. So let's look at this right here. This says that just as you have used inequalities to describe graphs on a number line, you can use inequalities to describe regions of a coordinate plane. Notice that here, x is less than 1 on a number line would look like this. Everything that is shaded less than 1 with an open circle on 1. But on a coordinate plane, you're going to shade everything less than 1. Now notice that your line is a dotted line. And the reason is, just like an open circle would represent that 1 is not a solution. A dotted line would represent any point on that line is not a solution of the line or of the inequality. So we're going to start talking about a linear inequality. Here's your vocab word. A linear inequality describes a region of a coordinate plane that has a boundary line. Now you're like, what is a boundary line? A boundary line is when you take your inequality and you write it as an equation. So for example, if you have the inequality x is greater than 5x minus 1, the boundary line would be graphing y equals 5x minus 1. So a boundary line is just when you take your inequality and you write it as an equation. So back to our representations here. The solutions of an inequality are the coordinates of the points that make the inequality true. So let's look at this one. If you graphed y equals x plus 1, you would just have the line. Because we're talking about y is greater than x plus 1, it would mean anything greater than on the line, which means anything on the line is not true. So each point on a dashed boundary line is not a solution. I would make a note of this. A dashed line means it is not a solution. So over here we have y is less than or equal to negative 2x plus 4. Because it's equal to, anything on this line would be a solution. So each point on a solid boundary line is a solution. Dashed, not a solution. Solid is a solution. So as you can see in the graphs above, you can tell from the inequality whether to shade above or below the boundary line. This only works when your inequality is solved for y. Make sure you understand that. It must be written in the form y is less than or y is greater or less than or equal to. So if it's y is less than or equal to, less than means you're going to shade below. For an inequality written in the form y is greater than and y is greater than or equal to, you're going to shade above because you're going greater than. This does not work for anything that is not solved for y. So example number 1. Example number 1, we want to graph this inequality. Step 1, we are going to graph the boundary line y equals 2x plus 3. So I'm just, since this is in slope-intercept form, going to graph using slope and y-intercept. So 3, and I go up 2 over 1. Now, because it is less than, that means anything on the line is not a solution. So I draw a dotted line. Because it's solved for y, it says less than. Anything less than, which is to the right here, is a solution. Now here's what I suggest. While we just went over that less than a shade below, greater than a shade above, there is a foolproof way that will work no matter what it looks like. And here's what you do. So I want you to listen, this can get confusing. Anytime you split a coordinate plane into two regions with a line or an inequality, you're going to have two sides, the left and the right, up and down, whatever. One side represents all of the true solutions. One side represents all of the false or not true solutions. What you have to do is pick a point that is not on the line and see if it's true or false. So for example, let's say you did not know this side, all this blue side, let's say you didn't know it was a solution. Here's what you would do. The easiest point to always pick is 0, 0. So I'm going to pick 0, 0. Now you're like, I don't understand what we're doing. We are picking 0, 0 to test if it is true or not. So I'm going to plug it in to my inequality. I'm going to plug in 0 for x and 0 for y. So 0 is less than 2 times 0 is 0 plus 3. Is this true? Is 0 less than 3? This is true. Therefore 0, 0, which is here, and I'm making a point out of this, that's 0, 0. That means you picked a point on the true side. Therefore, this is true. Let's say you didn't pick 0, 0. Now 0, 0 is the easiest one to pick. Let's say you picked 0, 5. Now you'll notice 0, 5 is right here. So if you plugged in 0, 5 to y is less than 2x plus 3, that would give us 5 is less than 2 times 0 is 0 plus 3. You're going to get 5 is less than 3. 5 is not less than 3. So this point up here, this 0, 5, this is the false side, which means you would shade the true side. So you have to figure out which side is true, which side is false. If you plug something in and it's true, then that's the true side. If you plug something in and it's false, then the other side is true. So let's try this example. Let's just do example B. Example B, we have the inequality y is less than or equal to 2x. So my y-intercept would be 0. My slope is down 2 over to the right 1. It would be a solid line because a solid line represents solutions. And I'm going to make this a little better here. It's a solid line. Now one of these sides is true and one of them is false. One side is true, one side is false. I cannot pick 0, 0 because it's on the line and we already know it would be a solution. So I'm going to pick any point that's not on the line. So I'm going to pick 1, 1. I'm going to plug in the x and y value. That would be 1 is less than or equal to negative 2. Is 1 less than or equal to negative 2? No. So that means 1, 1. This point right here is false. So this is the false side. So then you would shade the other side, which would be true. All right, example 2. Rewriting to graph an inequality. Now, I'm not actually going through what the book is saying here because personally, you don't have to do it like this. You can graph however you want. However you want. So, if you want, you can solve this equation for y. That would absolutely work. You could also use intercepts. So you could do one of two things. I could find, let's solve for y. I'll do that. 3x minus 5y is less than or equal to 10. I subtract 3x on both sides. I now divide everything by negative 5. Because you divide by negative 5, the inequality flips. Don't forget that. So y is greater than or equal to 3/5 x. Negative 3 divided by negative 5 is positive 3/5. And 10 divided by negative 5 is negative 2. So if you graph this, y-intercept is negative 2, up 3 over 1, 2, 3, 4, 5. Would it be a solid or a dotted line? It would be solid because it says equal to, so therefore anything on the line would work. Now we have to shade. I would pick a point not on the line. 0, 0 is the easiest one. It's not on the line. So 0, 0 would give you this. Is 0 greater than or equal to negative 2? That is true. So therefore 0, 0 is on the true side. So this is the side you would shade. You would shade anything above the blue line. Now we are going to model real-world situations. We're going to take what we know and write it as a real world. So, I'm going to put this, I'm going to move this. This is kind of what we already went over. You don't need to write this down. I already went over it, but you more than welcome can write it down if you want. Many situations are modeled by inequalities that have a boundary line in standard form. You can use the intercepts to graph the boundary line of the inequality, but then you must choose a test point not on the boundary line to determine whether the solutions are above or below the boundary line. So let's do this problem. Suppose your budget for a party allows you to spend no more than $12 on peanuts and cashews. Peanuts cost $2 a pound and cashews cost $4 a pound. Find 3 possible combinations of peanuts and cashews that you can buy. So I'm going to move this out of the way. Actually, I'm going to make it smaller. Move this up. So first thing, we have to write an equation. This should be fairly easy. We don't know how many pounds that we need. So we know that peanuts cost $2 a pound. Cashews cost $4 a pound. We want no more than $12. So that means no more than means less than or equal to 12. Now you graph. Now, and if you don't like that because you don't want to graph P and C, you can always graph like 2x plus 4y is less than or equal to 12. You're more than welcome to do that. But then make note that x would represent peanuts and y would represent cashews. So now you can graph using intercepts. Intercepts absolutely would work. Remember, when you solve for intercepts, to find the y-intercept, you plug in 0 for x. To find the x-intercept, you could plug in 0 for y. So let's see what we want to do here. Now normally you would graph, actually I'm going to get rid of this graph. The reason is we don't need negative peanuts and cashews. So, positive. I have x, I have y. This would be x would represent peanuts, so the amount of peanuts. This is the amount of cashews. So let's find the intercepts. If we plug in 0 for y, that would give me 2x. And remember, we just want intercepts, so you're going to pretend it's an equal sign. 2x equals 12, so the x-intercept would be 6. The y-intercept, if you plugged in 0 for x, would be 4y equals 12. Divide by 4, the y-intercept is 3. So we would graph. The x-intercept is 6. The y-intercept was 3. Now we don't draw arrows at both ends. Oh, that's really bad. Let's try that again. We don't draw arrows at both ends because we can't go into the negatives. So there's my line. Now we have to shade. I want to know what? Well, pick 0, 0. That's the easiest one. Plug in 0, 0 to your inequality. You would get 0 times 2 plus 0 times y. Basically, you're going to get 0 is less than or equal to 12. So, is that true? Is 0 less than or equal to 12? Yes. So then you'd shade. Now, you'd shade anything below the line, but the problem is you can't go anything below into the negatives because you can't have negative amounts of peanuts and cashews. So now it says find 3 possible combinations of peanuts and cashews you could buy. Now also, you could buy anything on the line or in the blue region. So I'm going to find 3 possible ways. So I could pick this point here. Actually, I'm going to mark it in green. This point's on the line. That means 0, 3. 0, 3 means what? One combination would be I buy 0 pounds of peanuts and 3 pounds of cashews. Would that give you 12 bucks or less? Absolutely it would. Example number 2. I'm going to pick this. Here's a point right here. 1, 1. 1 pound of peanuts 1 pound of cashews. And the third one, I could pick this. 3-1. I could say 3 pounds peanuts and 1 pound of cashews. There's a numerous amount of answers you could have here, but anything that's on the line or below would be a solution.